Now we continue with the interpretation of partial differentiation. Okay, let's look at these figures. Let's call this one here fig 1, figure 2, and figure 3. Let me try to label them. This is y, x, z, y, x, and z, and x and y. Good. Now, for the one-dimensional case, okay, if we have a function of f of x, which is this function I have here, all right. Now, f prime of s at a is a slope. You know, x equal to a is a line that is parallel to the y-axis. Okay, that crosses x at a. So it goes up like that. All right. Now, at the point where this line here meets this curve, if we take the slope of that curve, that will give us f prime at a. Good. Now let's look at. I hope you can see what I write here. Let's look at fx at ab. Now fx at ab. What this one here means is we are finding the slope. We want the slope of the tangent line to the trace caused by b. Now, the trace caused by b, okay, is here, you know, once we are differentiating with respect to x, y is what? Fixed. Now, y fixed means that b is fixed, okay. Now, the plane y is equal to b is this plane, okay, and it's parallel to the x-axis and it goes up, right? It's a plane. The plane is like a sheet, it goes up. So that plane here will go to cut this is our surface. If you look at this diagram, this portion here is what we call the trace. The outline is the trace. Okay. So the slope to the trace. So here, f of x at ab, from here, where it first cuts our surface, right? I can find the slope to that trace. Okay, at the point A, B. At the point A, B. So that's the representation of this. It is the slope to the trace caused by B. Alright, f of x at AB is the slope to the trace caused by B. Likewise, the slope of the tangent line to the trace caused by B. Likewise, f of y at A, B. Here is the plane x equal to b. That will cause our trace. So let me see what I can do that one here. When this one here cuts, it will chop here off. So some portion here will be off. Right. Good. When that portion is off, let me deepen it a little. When that portion is off, right? The tangent line to this trace, the tangent line, the slope of the tangent line to this trace at the point AB is given by that. Alright, that is the interpretation. Okay, I hope you got that one. That is the interpretation. Okay, so you could be asked to find the slope to the trace, the traces to z is equal to 10 minus 4x squared minus y squared at the point 1, 2. Now, the slopes to the traces, right? Now, first, we find fx and fy. Or let me say zs and zy, right? Okay. Now here, zx, differentiating z partially with respect to x. Differentiating z partially with respect to x will give us minus 8x. And differentiating z partially with respect to y will give us minus 2y. Okay, so the slope to the trace caused by 2 is going to give us, that is zx at 1, 2 is going to be, we put 1 here and we get minus 8. Now this is the slope to the trace, okay, caused by y is equal to 2. And the slope to the trace caused by x is equal to 1 is going to be that. And here, in place of y, I put 2 minus 4. Okay. Now, we try to find the equation of the tangent line to the trace. The equation of that tangent line to the trace. Okay. Okay. Now the equation of the surface of a vector function is as follows. R of x, y is equal to x, y, and f of x, y. Here, knowing that z is equal to f of x, y. Z is equal to f of x, y. Okay. Now, at the point A, B, and f of AB, if z is equal to f of x, y, right? When we put AB here, we get f of AB. Okay. Now there's a point A, B, and f of A, B. Now the tangent vector for the trace with fixed y, since y is fixed, then it's going to be Rx is, if I differentiate this with respect to x, this is going to give me 1. This, there is no x to give me 0, and this will give me f of x at that. Okay. Now this is the slope, the equation of the tangent line. This is the tangent vector, right? Caused by fixed y. The tangent vector caused by fixed z and fixed x is going to be that x, y. If we differentiate r with respect to y, we are going to get here 0, 1, and fy of x, y. Now, at the point AB, f of AB, the equation of the tangent line. So there are two. The equation of the tangent line caused tangent line with fixed y is going to be r x is equal to a b f of ab plus t multiplying 1 0 fx at ab. Now this is the equation of the tangent line with fixed y. Okay, the equation of the tangent line to the trace. I didn't bring it, please. To the trace. Let me do it on top, okay? The equation of the tangent line to the trace with fixed y is the equation of the tangent line to the trace with fixed y is given by the vector. So we put this one here, and at the point A, B, C, A, B, F of A, B, plus T, 1, 0, and Fx at 1 at AB. Now the same applies to this. The equation of tangent line to the trace with fixed x will be given by that it is t, not x. It is t. With fixed x will be given by a, b, f of a, b plus t of 0, 1, fx at a, b. Okay.